Okay, we'll talk about finding domains of equations. These particular equations will be um, rational functions, ones with the radicals on them. And last time we were looking for domains when we were dealing with rationals. Rationals were basically equations that had numerators and denominators with x's in them. Those were our rationals. And the way we found the domain was knowing that you cannot have zero in the denominator. So we took the equation, the expression out of the denominator, and quickly solved for x. And this let us know that out of all the numbers, you cannot use 4, the number line, in this expression. So you cannot use that for input. For radicals, the idea of that is that whatever's inside, let's say, is an expression inside with an x. Um, that expression can never be negative. You can't put a negative under a radical. You put 0 or positive numbers. So what we do to find a domain is we take the expression that's in here and we set it greater than or equal to 0, and then we solve for x. So let's find the domain of these expressions here. We have x plus 4 under the radical. And so we're going to take the expression out of the radical. In fact, the expression inside the radical is called a radicand. So the x plus 4, again, that's called the radicand. And the d is silent. And we set it up greater than or equal to 0. Okay. Then we solve for x. So minus 4 minus 4. We end up with x is greater than or equal to negative 4. Okay, so this is our domain in set notation. X is greater than or equal to negative 4. Now, the graph of that would be a closed circle at negative 4 and going to the right. Okay, that's the graph that it represents that. Then finally, interval notation would be negative infinity to the left, backwards. Negative 4 to the left, bracket negative 4, and then positive infinity to the right. So these are 3 ways to express the solution for the domain. Okay, let's go here number 2. Number 2, we're going to take the radicand, which is everything under the radical, out to x minus 4 and set it greater than or equal to 0. And then we're going to solve for x. Okay, now I have 2x greater than or equal to 4 after adding 4 to both sides. And then dividing both sides by 2, we get x is greater than or equal to 2. And this is our set notation. The graph of this will be a solid at 2 and will be graphed to the right. Okay, so that's our graph of this on the number line. And the interval notation will be bracket at 2, positive infinity, and then parentheses. This represents the domain. Once again, the domain tells you all the possible input for a function, all the numbers that can be used to put into the equation that you're working with, and what numbers you can't use as well. Okay, once again, we're going to find the domain of these 2 radical functions. So we're going to take the negative x plus 4, the radicand, and set it greater than or equal to 0. And then we're going to solve for x. So subtracting 4 from both sides. And with negative x is greater than or equal to negative 4. This negative x can be treated as negative 1 times x. So I'll divide both sides by negative 1. And we'll get a positive 1x. We'll get a sign change here. It's go from greater than to a less than equal. So we're divided by negatives, and this will become positive 4. So our domain will be x is less than or equal to 4. The number line for that will be a solid at 4, which means we're including 4, and then all the numbers to the left of that. The interval notation for this will be negative infinity, parentheses negative infinity, to 4 in bracket. So this represents our domain. Okay. Further, number 4 here. To find the domain, we're going to take 7 minus x and set it greater than or equal to 0. And then we'll solve for x. So we'll get rid of this positive 7 by subtracting 7 from both sides. We end up with negative x is greater than or equal to negative 7. Again, this negative x will treat it as a negative 1x. So if we divide by negative 1, as a result, we'll get x, a sign change here instead of greater than becomes a less than sign, and a positive 7. Now that we have our set notation, let's go ahead and write our graphic. That'll be a solid at 7, and this will be less than, so it's left. Furthermore, interval notation will be parentheses negative infinity to 7, including 7. So we'll put a bracket. So this is how we express the domain. Okay. Now, if the answers are on your sheet, do not neglect to write these just because the answers are there. Don't just stop and say, okay, well, I got the answers there, so I don't need to write all the rest of this. Okay. All right. We're going to find the domain of these functions, and they have quadratic expressions inside of them. So we'll start with x squared minus x minus 6 is greater than or equal to 0. Okay. I'm going to start off by factoring this in order to solve it into two binomials. Okay. First, we'll have x squared broken into x times x. Then lastly, we'll look at 6. 6 will be either 1 times 6 or 2 times 3. I'm going to choose the 2 times 3 for the last terms. So in the middle here, we get 2x, and outside here, we get 3x. Okay, so we have a negative here. That means the signs have to be different, and we have to get a negative 1x. So different signs would be, let's say, positive 2, negative 3. Those are different signs. And these two different signs do add up to negative 1x. So all this matches. So we'll first have a positive here, and then a negative there. Positive, then negative. So I'll take both of these and solve for x. X plus 2, set equal to 0. X minus 3, set equal to 0. And then when I solve, I'll get the answers of x equals negative 2. And I'll also get x equals 3. All right, I'm going to put these two solutions on the number line. Okay, so these will be part of the domain. The rest of the domain, so all the pieces that will be greater than 0, or shall I say positive pieces. So we need to find positive intervals along here. In order to find positive intervals, we need to use test points. So I'm going to use a test point of negative 10 for this side. I'm going to use 0 for the middle, and then I'm going to use positive 10 to test this right side. So x equals negative 10 will tell me if this area right here is positive or negative. So negative 10 plus 2 is negative 12. That's a negative number. Negative 10 take away 3 is negative 13. Negative 13 is a negative number. So we're multiplying a negative number times a negative number. Negative times negative is positive. So this area represents positive values. Let's go to this area. Now, if x is 0, we have 0 plus 2, which is 2. That's a positive number. 0 minus 3 is negative 3. That's a negative number. So a positive number times a negative number is a negative. So that means this area has only negative numbers. Now this last area, let's put in x is 10. If x is 10, we have 10 plus 2, which is 12. That's positive. And 10 take away 3 is 7. That's positive. So positive numbers multiplied with positive numbers will give us positive. So the positive portions of this graph will be here and here. So let's represent that as this part right here. It's represented as x is less than or equal to negative 2. And we have this portion right here, which is x is greater than or equal to 3. The interval notation for this area would be negative infinity to negative 2, bracket, union with this area right here, which is bracket 3 to positive infinity. Okay. So this would represent your domain. So we have the graph. Basically, I can erase this, and this will be our graph. So let's kind of erase this part right here. Just use this right here as our graph. Here we go. And this represents our domain. Okay. Number 6. We're going to find the domain of this expression. And again, the radicand contains a quadratic. So we'll take x squared minus 7x plus 6, and we'll say that it's greater than or equal to 0. I'm going to solve this by factoring. I'll factor into two binomials, which will be x times x, which will be the first term, represents x squared. Now for 6, it's either 1 times 6 or 2 times 3. This time, I'm going to use 1 times 6. So in the middle, I'll get 1x. On the outside, I'll get 6x. According to this, signs need to be the same on both of these, and we need to get a negative 7x. So the signs that I'm going to use on both of these that are the same, I will use a negative and negative. Because together, these become a negative 7x when you combine these two. And that matches the middle. So I need a negative first and a negative second. So negative first, negative second. Okay. All right. Let's go ahead and solve for both of these factors. X minus 1, set that equals 0. X minus 6, set that equals 0. And solve for x. Okay. When I solve for x, I get x equals 1 and I get x equals 6. So we'll put those two values on the number line, and they'll be used for the domain. And then for these areas right here, I'm going to use test points. I'll use negative 10 for this area. For this area right here, let's use 3. And for this area right here, let's use 10. Okay, so start with negative 10. Negative 10 and negative 1 is a negative 11. That's negative. Negative 10 and negative 6 is negative 16. That's negative. So a negative number times a negative number is positive. So this area is positive. Let's put in 3 now. 3 take away 1 is 2. 2 is positive. 3 minus 6 is negative 3, and that's negative. So a positive times a negative means this area is negative. Now let's put in 10 for x. 10 take away 1 is 9. 9 is positive. 10 take away 6 is 4. 4 is positive. So positive times a positive gives us a positive. Okay, let's get the test point out of the way. All right, so let's put it a little higher. All right, so this right here can be represented, this is the positive part, this will be represented by x is less than or equal to 1. And this part right here can be represented by x is greater than or equal to 6. Furthermore, the interval notation for this portion right here, the domain, will be negative infinity to 1 bracket, union with this portion right here, which is positive, which will be bracket 6 to positive infinity in parentheses. Okay. So this is the domain interval notation, set notation, and the graphic domain. Let me just erase this little part right here. And so we can use this for the graph. Okay. So this is how we can express the domain. It looks a little weird.